Okay, so I wanted to share a video just for you, Chelsea. I'm sorry I got back to your email this late. I didn't see it. But basically answering your question about the practice problem. So this is the practice problem. It's saying find the zeros for this quadratic. Okay, notice, why is it a quadratic equation? Because the highest term, which is x squared, the exponent is 2. So that makes it a quadratic function. So if we go to the guide, we have different ways of solving quadratics. These are all quadratic equations. Why are they quadratic equations? Because they're all in the form ax squared plus bx plus c. But again, if you notice the problem that we're given, do we have this bx term, which is just x to the first power? No, we're actually missing this term. So what we have is ax squared and c. We just don't have that bx term. So notice in all these factoring problems, we have that bx term. We have the bx term, we have the bx term. And even with when we have to use a quadratic formula, we still have that bx term. So what happens when we don't have the bx term? So just like the problem that's given, we don't need a factor. Instead, what we do is we basically set the x squared equal to the number. Okay? The number that's given. So if we go back to the problem, we have x squared minus 30. So 30 and 14, they're basically c terms that we could combine. So what I want to do is I want to isolate that x squared and set it equal to my c term. And again, instead of factoring and using the quadratic formula, all I have to do is use the square root property, which is this essentially. The square root property tells me to take the square roots of both sides, and if I do that, then I have the positive and negative version of that side. So let's do this work on the whiteboard. Let me see if I could clear. Okay, perfect. Okay, so we have x squared minus 30 equals 14. So again, since I don't have, oh my god, since I don't have that bx term, since I don't have this middle term, I'm basically just doing ax squared equal to c, and then just solving for x. So that's what I'm going to do. I'm going to get all my c terms, so that individual number, all on one side together combined. So I'm going to add 30. Again, my goal is to isolate that x. So I want to get x by itself. So I have x squared is equal to 44. Okay, now that this is the case, I get to use the square root property. Okay? And again, my goal is to solve for x. Just like when I solve, or just like when I factor or anything, my goal is always to solve for x. So look, solution set is x equals blank and blank. X equals blank and blank. Because I have a quadratic, then I have an x equals something. So I'm solving for x still. So I take the square root to both sides. And what happens when I take the square root to both sides? Remember, I get x by itself, which is the goal. But now I get x is equal to the positive and negative version of that side that I square rooted. So going back to the problem, I have x by itself. But now I don't have just square root 44. I have the positive and negative version of square root 44. Okay, so now why is that? Why do we, in the square root property, why do I have the positive and negative version of square root? Well, because let's say I wanted to solve for a simpler problem where I think it shows y clearly. Let's say I have x squared is equal to 4. Now, you can tell me just by looking at this problem that 2 squared equals 4. So even if I don't solve for x, I know 2 squared equals 4. But also keep in mind, what else squared equals 4? Negative 2 squared also equals 4. So if I do 2 times 2, I get 4. If I do negative 2 times negative 2, I also get 4. So that's why we have that positive and negative version. So again, if I were to solve for this, I get x is equal to the positive and negative version of square root 2. I mean, oh my god, the square root 4. And then if I were to simplify this further, I would see that I have the positive and negative version of 2, which is 2 problems, right? It's saying x equals 2 and x also equals negative 2. So I have 2 solutions for x. Notice I have the positive and negative version, okay? So that's the same case here. Anytime we take the square root to both sides, once I isolate that x on this side, I have the positive and negative version. And just like I simplified the square root of 4 to 2, we can simplify square root 44 a little bit. So now I want to choose factors of square root 44 that have a perfect square. So what are some factors of square root 44? 11 and 4. The reason I chose 4 and 11, and I think those are the only 2 factors of square root 44 that I could think of at least. Yeah, that I can pretty much 22 times 2. That's another one, but that one's not going to help me because I want a factor that is a perfect square. So the reason I chose 4 and 11 is because square root 4, what is square root 4? Simplified to a nice integer 2. So 4 is a perfect square. That's why it's a perfect factor for square root 44 to choose in order to simplify my square root here. Okay, makes sense? So x is equal to the positive and negative version of 2 square root 11. Again, this is 2 problems, just like it divided here. It's saying x is equal to 2 square root 11, the positive version, and x is equal to negative 2 square root 11. Okay. Just recapping, again, this is a quadratic equation, and I could solve for x, but it's just not in a traditional sense. Why? Because I don't have bx. So because I don't have bx, I'm basically just setting the x squared equal to c, and I'm solving for x. And when I solve for x, I have to take the square root to both sides, which indicates that I have to use the square root method, which tells me that I have to, once I get x by itself, I really have the positive and negative version of this side.